friends, welcome to Quick Learn tutorial series. In this video, I will explain you special function registers of 8051 microcontroller. This is lecture number 9 of microcontroller series. So let's start with the topic registers in 8051 microcontroller. Before I discuss registers in 8051 microcontroller, first we know about what do you mean by registers. Register is basically a small place in CPU that can store a small amount of data used for performing various operations such as addition, multiplication, division, and loads the resulting data on the main memory. The second function of register also contain the address of the memory location where the data is to be stored. So the size of register is very important for modern controllers. For example, if we have a 16-bit register, a CPU try to add two 32-bit number and give a 64-bit result and store into the 64-bit register. So we can say that register is basically the main part of the microcontroller or any processor that provide a fast way to collect and store data. If we want to manipulate data with a controller or processor by performing some operation just like addition, subtraction and so on, we cannot do that directly in memory. But we need some register to process and store the data. So microcontroller contains several different type of register that can be classified into two types: general purpose register and special function register. General purpose register are basically byte addressable register, whereas special function register is bit or byte addressable register. So as we know, 8051 microcontroller basically consists of 256 byte of RAM. RAM is the data memory in 8051 microcontroller, which is divided into two ways: 128 byte of general purpose memory and 128 byte for special function memory, that is called special function register. The memory which is used for general purpose, that is called RAM, and the memory which is used for special function register contain all the peripheral related register just like accumulator register, B register, timer register, counter, interrupt related register. So this type of register having some special function associated with it, and this type of register is basically used to perform some control operation in 8051 microcontroller. So here I first give a brief introduction of general purpose memory or general purpose register. The 128 byte area of RAM is allotted for general purpose memory. This is started from 00H to 7FH. These general purpose memory area is divided into three parts. First part is called register bank area. Second part is called bit addressable area, and third part is called scratch pad area. As we know, 8051 having four register bank, that is B0, B1, B2 or B3 bank. Each bank contain different general purpose registers such as R0 to R7. Now bank and registers. As I have already told, 8051 having four register bank: bank 0, bank 1, bank 2, bank 3 in the general purpose area of RAM. So each bank contain 8-bit register, that is starting from R0 to R7. The bank 0 address is starting from 00H to 07H. Bank 1 address is 08H to 0FH. These address given in hexadecimal. Bank 2 addresses is starting from 10H to 17H, and bank 3 address start from 18H to 1FH. Each bank having 8-bit register. All these register are byte addressable register, but the important point is data transfer between general purpose register to general purpose register is not possible. These banks are selected by the program status word register. So what is program status word register, PSW register, we will discuss later, and how these banks are selected by using PSW flag we will also see later. So these are the bank and registers of general purpose register. Now special function register. As I have already told that 8051 having 256 byte of RAM which is divided into two parts, 128 byte for general purpose memory or 128 byte for special function register memory. So special function register are the upper 128 byte of RAM in 8051 microcontroller. These registers contain all the peripheral related register like P0, P1, P2, P3 register, timer, counter register, serial port register, interrupt related register. The special function memory address here we see started from 80H to FFH. This is 128 byte. The special function register is implemented by bit addressable or byte addressable registers. So basically 21 special function registers in 8051 microcontroller. They are classified in different ways. The blue background show the input output port special function register, that is P0, P1, P2, P3 registers. The yellow background show the control special function register, that is TCON, TMODE register, SCON register, IE register, IP register, PSW register and PCON register. Here the physical address of these registers is given. Next is green background are other special function register, that is accumulator register. So the accumulator, the physical address of accumulator is E0H. The B register, stack pointer register, data pointer register, DPL or DPH register, timer or counter register, that is TL0, TL1, TH0, TH1 register and SBUF register. So total 21 special function register is mentioned in the special function area of RAM. Now these register are bit or byte addressable register. So out of 21 register, the accumulator register, B register, port register P0, P1, P2, P3 and IE register are bit addressable register and remaining all other register are byte addressable register. So in this video, I will explain you all the special function register and their functionality, because special function register having a special function associated with it. Now first is the accumulator register. Accumulator is also known as A register. It is an 8-bit register starting from E0 to E7. These are the bit address of the accumulator register. The physical address of accumulator register is E0H in the special function register area in 8051 memory. This register are basically a bit or as well as byte addressable register. This register is basically used to hold data and receive the result of all the arithmetic and logic operation performed by ALU. This register is direct addressable and the physical address is E0H. If we want to access the second bit of the accumulator register, we use bit address E1H. If we want to access the fifth bit of the accumulator register, we use bit address E4H. Now next is B register. B register is very similar to accumulator register. It is also an 8-bit register. This is bit or byte addressable register. This B register is basically used alone with accumulator in multiplication and division operation. These two operations are performed on data that is stored only in register A or register B. During multiplication operation, one of the operand, that is multiplier or multiplicand, is stored in the B register and also the higher byte of the result. In case of division operation, the B register holds the divisor and also the remainder of the result. So in this way we use B register in multiplication and division operation. It can also be used as a general purpose register for normal operation. This register is also used as an auxiliary register by programmer to store temporary results. The physical address of this register is F0H, and these are the bit address of B register. If we want to access bit number 1, we use F1 bit address. If we want to access bit number 3, we use F3 register. Now next is PSW register. PSW is basically a program status word register. It is also known as flag register. It is an 8-bit register. It is bit or byte addressable register. This register contains the status information of all the operation performed in the microcontroller. So the physical address of the PSW register is D0H. Now I will explain all the function of bit of PSW flag register. So first, the most significant bit of PSW flag register is carry flag. If any arithmetic and logic operation is performed and carry is generated, then this flag is set, otherwise reset. It means if carry is generated, this PSW 7 bit is 1 or set, otherwise if carry is not generated, this is reset or the value of this bit is 0. Next bit is PSW 6 bit. This is allotted for auxiliary carry flag. Auxiliary carry flag is basically used for a BCD operation. In BCD operation, if carry is generated in bit number 3 or bit number 4, then it is set, otherwise it is reset. Next is bit number 5. This is for F0, that is 0 flag or user defined flag. Next is bit number 4, that is PSW4 and PSW3 bit. These two bit are working together. These are register bank selection bit. Register bank, as I have already told, is a portion of general purpose register. Next two bit, that is PSW4 or PSW3 bit. These two bit are work together. These are used for register bank selection bit. As I have already told, 8051 microcontroller having 4 register bank, that is bank 0, bank 1, bank 2 and bank 3. So out of 4 register bank, how we select a particular bank? So by the combination of these two bits, we select a particular register bank of general purpose area in 8051 microcontroller. So if the combination of these two bits is 00, register bank 0 gets selected. If the combination is 01, register bank 1 gets selected. If the combination is 10, register bank 2 gets selected. If the combination is 11, register bank 3 gets selected. So in this way we select the register bank by using PSW register. The next bit is PSW 2 bit. This is allotted for overflow flag. If any arithmetic result is generated and overflow means after bit number 7, bit number 8 is also generated, this overflow flag bit is set, otherwise it is reset. Next bit is PSW1. This is reserved for future work. Next and the last bit of PSW register is PSW0. This is allotted for parity flag. This parity flag is set when in arithmetic or logic result we have 8 bit. Out of 8 bit, if number of 1 is odd, then this parity flag bit is set, otherwise it is reset. So in this way, program status word register reflect the status of the operation of 8051 microcontroller. Now next is data pointer register. Data pointer is basically an 16-bit register and it is basically used to hold 16-bit address of the data memory. We know that in 8051 microcontroller we have program memory also and data memory also to store program and data. So to point the data or to hold the 16-bit address of the data memory, we use 16-bit register, that is called DPTR, data pointer register. This register is hold the 16-bit address of the data memory. This register is physically the combination of DPH or DPL register. Both are 88-bit register in special function area of internal RAM. The data pointer can be used as a single 16-bit register also, and it is also used as a 88-bit register, that is DPL or DPH register. when 8-bit data pointer register are used for accessing internal RAM and special function register, whereas 16-bit data pointer register is used for accessing external memory. But DPTR don't have a physical memory address in special function register area, but the DPL and DPH have separate address in special function register area in internal RAM. That is, for DPL the address is 82H or DPH address is 83H. So here we see DPTR is a data pointer register. It is an 16-bit register. This 16-bit is divided into two 8-bit register, that is DPH data pointer higher byte register and DPL data pointer lower byte register. We can use total 16-bit DPTR register as well as we use 8-bit DPH or DPL register also. So the physical address of DPL register in special function register area is 82H and the physical address of DPH register is 83H. But DPTR don't have any physical address in the special function register of internal RAM. Now, so next is stack pointer register. Before I discuss stack pointer register, first we know about what do you mean by stack. A stack is basically a section of RAM used by the CPU to store information such as data or memory address on temporary basis. So, the register used to access the stack is known as stack pointer register. Stack pointer is also an 8-bit register. It is basically used to point out the top address of the stack and indicate the next data to be accessed. Stack pointer register is basically 8-bit register. It can take a value of 00 to FFH. When 8051 is initialized, the stack pointer register contains the value 07H. The stack pointer can be accessed using push, pop, call instructions. If we want to store data or when writing a new data byte into the stack pointer is automatically incremented by 1 and the new data is written in the address stack pointer plus 1. Or when we read data from stack, the data is retrieved from the address in stack pointer and after that the stack pointer is decremented by 1. So if we store data into the stack, that is called push operation. The stack pointer get incremented and this is called push operation. And if we retrieve data from the stack, this is called pop operation, and in this operation stack pointer is decrement by 1. So it is an 8-bit register. The physical address of stack pointer in special function register is 81H. Next is input output port register. As we know, in 8051 microcontroller basically consists of 4 8-bit bidirectional input output ports. These ports are port 0, port 1, port 2 and port 3. All are 8-bit port and every port is bidirectional input output port. Bidirectional means they both work as an input port as well as work as an output port also. So each port having a corresponding register with the same name, that is called port 0 register, port 1 register, port 2 register and port 3 register to store data temporarily. These 4 ports having a physical existence in the spatial function area of internal RAM. So port 0 address is 80H, port 1 address is 90H, port 2 address is A0H and port 3 address is B0H. These are the physical address of the 4 ports in spatial function area. All these port registers are both bit or byte addressable register. Next is timer and counter of 8051 microcontroller. 8051 has basically two 16-bit programmable timer and counter. These are timer 0 and timer 1. Timer or counter is programmable. It means we can program this timer or counter in different operating mode. Or 16-bit means we can load 16-bit data in this timer or counter. These timer or counter work as a timer also and work as a counter also. When they work as a timer, they generate time delay, or when they work as a counter, they count number of events happening outside the microcontroller. So, for this timer or counter, 8051 microcontroller contain two special function register, that is called TMODE register and TCON register. These two registers are basically used to activating and configuring timer and counters. Other than these two registers, timer and counter of 8051 contain timer 0 register also and timer 1 register also. So what is timer 0 register? Timer 0 is basically a 16-bit register. Here we see in the diagram bit 0 to bit 15. This 16-bit timer register is divided into two 88-bit registers because we know that 8051 microcontroller is a 8-bit microcontroller. So this 16-bit is accessed as two separate 88-bit register, that is TH0 register or TL0 register. TH stands for higher byte of timer 0 register and TL stands for lower byte of timer 0 register. So if we have total 16-bit data, so we can use timer 0 16-bit register. But if we have 8-bit data, we can use TL0 register or TH0 register. But timer 0 don't have any spatial address or any physical address in the spatial function register area. Only timer TL0 and TH0 having the physical address in spatial function register area. So the physical address of TL0 is 8AH and the physical address of TH0 is 8CH in spatial function area of internal RAM. Next is timer 1 register. Same as timer 0 register, there is a timer 1 register also. This is also a 16-bit register. So we can access these 16-bit into two separate 88-bit registers. This is TH1 register for timer 1 or TL1 register for timer 1. Timer, if we have 16-bit data, we use timer 1 register to load that data. But if we have 8-bit data, we also use TL1 or TH1 registers. Timer 1 register do not have any physical address in the spatial function register area of internal RAM, but TL1 or TH1 have a physical address or a spatial space in spatial function area of internal RAM. So the address of TL1 is 8BH and the address of TH1 is 8TH. So these are the timer 1 or timer 0 registers. Now other two spatial function register of timer or counter is TMODE register and TCON register. So first I explain TMODE register. TMODE is a timer mode register. It is an 8-bit register. Here we see starting from D0 to D7. This register decides that in which mode timer is going to operate. It means this register set the operating mode of the timer 0 and timer 1. So out of this 8-bit, the upper 4-bit, that is D4 to D7, is allotted for timer 1 or counter 1, and the lower 4-bit, that is D0 to D3, is allotted for timer 0 or counter 0. The operation of these upper and lower 4-bit are just same. Here we see these 4-bit is functioning same just like the lower 4-bit. So first I explain the function of D7 bit of timer 1 and D3 bit of timer 0. Both are allotted for gate signal. So the function of gate is to starting and stopping the counter. If we want to start the counter, we set D7 bit is 1 and D3 bit is also 1. If we want to stop the counter, we reset D7 bit to 0 and D3 bit 0. Next bit, that is D6 bit of timer 1 and D2 bit of timer 0, decide in which mode these timer or counter will be operate. It means it will work as a timer or work as a counter. So if this bit is set to be 0, These timer or counter work as a timer and generate time delay. If this bit is set to be 1, the timer or counter work as a counter and count number of events. Next bit is D4 and D5 bit of timer 1 and D0 and D1 bit of timer 0. These two bits are used to decide the mode of operation of timer. Timer having basically 4 mode of operation: mode 0, mode 1, mode 2, mode 3. So the combination of these two bits define in which mode timer is going to operate. If the combination is 0 0, timer operate in mode 0. If the combination is 0 1, timer operate in mode 1. If the combination is 1 1, timer operate in mode 2, and if the combination is 1 1, timer operate in mode 3. These mode of operation I will discuss in my previous video, that is the timer and counter of 8051 microcontroller. So if you want to learn more about timer and counter, please refer my that video. The link of that video I will give in my description box. So this is TMODE register. Next is TCON register. Just like TMODE register, TCON register is a timer control register. This register is basically used to indicate the status of the timer, like overflow condition is achieved or not, control bit is set or not. So it is also an 8-bit register starting from TCON 0 to TCON 7. These 8-bit is divided into two group. The upper nibble is used for timer 0 or timer 1 control operation, and the lower nibble, that is TCON 0 to TCON 3, is used for interrupt related operation. So first I explain the upper nibble, this which is used for timer 0 and timer 1. So first I explain the function of TCON 7 and TCON 5 bit. These two bit are used for overflow flag bit for timer 1 and overflow flag bit for timer 0. If overflow condition is occur in counter, so these bit get set, otherwise reset. Next bit is TCON 6 or TCON 4 bit. These two bit are used for timer run control bit. For timer 1 or timer 0, it means this bit is used to starting up the timer. If we want to start the timer 1 or timer 0, we set this bit 1. If we want to stop timer 0 or timer 1, we reset these two bits. Next, the lower nibble of the TCON register. These lower nibble is used for interrupt operation. So first I explain TCON 3 and TCON 1 pin function. These two pin are used for interrupt enable function. For timer 1 and timer 0, this is used to enable the external interrupt. Next is TCON 2 or TCON 0. These two are basically used for external interrupt control signal. So if you want to detail study of timer or counter, so please refer my previous video, the timer or counter of 8051 microcontroller, lecture number 8. Now next is PCON register. PCON stands for peripheral control register. This register is an 8-bit register. It is used to control the power mode of 8051 microcontroller. It is located in the 87H of special function memory space. It means the physical address of PCON register in 8051 special function area is 87H. Using these two bits, that is PD and IDL, in PCON register, the microcontroller can be set to idle mode or power down mode. What is idle mode? During idle mode, the microcontroller will stop the clock signal to the ALU, but it given to the other peripheral like timer, serial, interrupt, etc. In order to terminate the idle mode, we have to use interrupt or hardware reset. Next is power down mode. In case of power down mode, the oscillator will stop and the power will be reduced to 2 volt. To terminate the power down mode, we have to use the hardware reset. Other than these two bits, the GF1 and GF0 bit are basically used for general purpose flag bit. These bits are used by programmer during execution. Now the most significant bit define a special function. This is for SMOD. This bit is used to control the baud rate of the serial port. So in this way PCON register is functioning. Next is SCON register. SCON stands for serial control register. Serial control special function register is used to control the 8051 microcontroller serial ports. It is also a 8-bit register. The address of SCON register is 98H in the special function register area in internal RAM. By using SCON register, you can control the operating mode of serial port, baud rate of the serial port, and sending and receiving data using serial ports. Now next is interrupt enable register. Interrupt enable register is used to enable or disable the individual interrupts. If a bit is set, the corresponding interrupt is enabled, and if the bit is clear, the interrupt is disabled. So it is also an 8-bit register. The physical address of this register is A8H in the special function area of internal RAM. The bit 7 of I register, that is EA. This is used to enable or disable all the interrupts. Now next is IP register, interrupt priority register. Interrupt priority is also an 8-bit register. The physical address of this register is P8H in internal RAM special function area. The IP interrupt priority register is used to set the priority of the interrupt as high to low. If a bit is clear, then the corresponding interrupt is assigned to low priority, and if bit is set, the interrupt is assigned to high priority. So according to this priority, high to low interrupt gets served. Next is peripheral data register. This is SBUF register. This is also an special function register known as serial data buffer register. This serial data buffer register is used to hold the serial data while transmission and recaption. This is also an 8-bit register, and the physical address of SBUF is 99H in special function area of internal RAM. So these are the 21 special function register in 8051 microcontroller. So hope you like the video. For more interesting video, please like, subscribe and share my channel.